Oh, are we streaming? Who knows? Who knows? Let's see. Let me make sure that my stream is doing what I think it's doing. Okay. Cool. Looks like I'm live. Ooh. Let me see if I can log into the chat here. Okay. All right. Might as well get started. What is the purpose of this stream? What is the purpose of this YouTube channel? My name is Ami. I'm a professional software developer. I've been working in the industry for almost 10 years, about 10 years, I would say, something like that. And it's obvious to me, it's been obvious to me that AI tools are now extremely powerful. And the things that people can do with AI tools for software development are just incredible, are just incredible. So I feel like this is not well understood. I feel like there are lots of people who might want to build things and don't know how to, don't know how to start, don't know that they actually probably can if they want to now with the help of AI. And when I tell people in my industry how powerful I think these tools are, I think people often disagree or don't take it seriously. And I think that's a mistake. I think the future is here and it's wild. And so I want to sort of explore that, test that, see if I'm right or if I'm wrong. And of course, the way I want to do that is just by building things purely with AI. What do I want to build? Well, I hope to build many things. Hope together we can explore different projects and come up with different ideas of what to build. Today, my plan is to build some games, some fun mini web games that I love. The two that I have in mind are 2048 and Tetris. We'll see how we do with that. I sort of think of this like a speed run. You know, how fast can we build it using purely AI? I don't want to touch code. I can touch code. I've built 2048 in about an hour and a half, I think, approximately. Was many years ago when I was really into the game and I thought it'd be a fun project. I think I was on a public transportation at the time. I was like, let me just build 2048. I got the idea in my head. So that's sort of like a benchmark, right? That's sort of like a typical, maybe middle of the bell curve software developer time for building a game like that. And so we're going to see today if we could do better in the speed run. So let's just jump right in. Let's not waste any more time. We're going to pull up Claude. And I'm going to share my screen. And yeah, like I said, the goal here is clear. The goal here is clear. We're going to see what we can and can't do with AI tools. Let me switch my view, see if this works. So far, so good. We're going to ask Claude Sonnet. I'm going to say, please give me instructions for creating a starter project, starter React.js project with TypeScript and unit tests. I think that should be what I need. So, of course, the vision here is to make some games and to do it in the form of a web app. There are other platforms you could build games for. You could build games for the phone. You could build games for desktop, whatever. We're going to go with web technologies. And within the ecosystem of web apps, there's many different tools and stacks and languages and frameworks we could be using. I'm going with React. Why React? It's very common. It's very mature. But honestly, the truth is, I think any other, there are many alternatives that would work just as well. It doesn't have to be React. I'm choosing to use TypeScript. I think TypeScript is good for AI coding for reasons I don't want to go into right now, but I'm sure we'll have time to talk about as we continue this project. And unit tests, which I think are very important for human developers and for AI coding, AI development, for exactly the same reasons, which we can go into as we go along. So we hit this. My goal is to not do any explicit coding, to not write any code, because I want AI to write all the code. But we are going to have to use the terminal, the command line a little bit. For beginners to whom the command line is not a familiar tool and command line commands are not familiar, there might be a little bit of learning to do here. I'm happy to assist if I can answer any questions, or AI can assist you. But we're just going to follow these instructions here to create our project. Create a new React project with TypeScript using create React app. So let's try this. We're going to run this command. This is a bash command, which we're being told to run here. And we have to give this project a name. Currently, the name is my app. My app is not bad for a starter project. And we're just going to run with this name. You know, obviously, if we had a more of a concrete vision of a particular project in mind with a name, we could replace this here with a real project name. But we're just going to roll with this. And a starter project is being created. Yeah, the trade-off of AI coding is that there's going to be periods of waiting, you know, which is interesting in this new paradigm as we let I mean, this isn't AI coding, this is just a regular command to create an empty project, but it reminds me that there's going to be periods of waiting as AI writes its code. So now we created this project, and CD means to change directory. We changed our directory to enter the directory of the project. And it says to install testing libraries and other common dependencies. Great. We're just following these instructions. Getting started up here. Good. That was fast. And this is a recommended project structure. Good. So now let's open up our project. And so for that, I'm gonna use Cursor. Cursor is the IDE that I use. Cursor is a AI enabled IDE. IDE stands for Interactive Development Environment. This is our new project, my app. This is the code that was created as part of this sort of starter template. There are a few other instructions here. Let me just pull this over, organize my windows. We have another instruction here that says update tsconfig.json with the recommended settings. Great, let's do that. So let's find tsconfig.json. I see it over there. And I'm just going to copy in the recommended settings. I suspect they might actually be the default settings. I'm not sure that what I'm about to paste in here is going to change anything. It actually, from a glance, looks to be basically the same. Maybe there were a few changes, who knows, but that's done. We're just following the instructions. Next, sample component with test. Interesting. It's giving me some code to write. We're not going to do the sample component with test. Should we do it? I'm debating. Let's do it. I think it's a good idea just to run through this to make sure we have a working unit test that we can run unit tests, because that's important to me. So let's go source components button.tsx source. We're going to add a new folder here called components. And then we're going to add a new folder here called button. And we're going to add a new file called button.tsx. And we are going to paste in the code that was given to me by Claude. This is just a pure copy paste from Claude, save. And then we have a corresponding unit test. So we go a new file, button.test.tsx, and let's copy in the unit test. Let's see if all this is going to work. Save. I'm already seeing some errors here. This is troubling. Yikes. Let's keep going. And now it wants me to run my test. Let's see if this works. It wants me to run npm test. And what's going to happen? So we have failed tests here. Okay, renders with a label. Unable to find an element with a text test. Okay, this did not succeed. And I'm not even going to worry about it. I'm not even going to go down this route, because we're going to switch over to a new tool, which will hopefully give us what we need. I'm going to undo this change. I'm going to delete these new directories. We're going to go purely with Cline. Cline is an AI coding assistant, very powerful, very cool. And we're going to use this for coding. But before we do that, let's start up our test project. Let's close this. Let's try npm start. This should launch our newly created test project, and it works. Great. We have a website. And so step one is done. Step one is done. We used AI, and it gave us our starter project. And now let's go. Let's start iterating, adding features. And we're going to just tell Klein what we want to do. And we'll see how fast we can go. We'll see what we can accomplish in a short period of time. So the first thing I'm going to say is, please add a nav bar to this website. On the nav bar, there should be a link for to do. Okay? The to do link should take you to a simple to-do list app. That's my request from Klein. Klein reads my request, and it asks me if I want to run these commands. We're just going to approve everything for this workflow here. We just want Klein to do all the work. We don't want to be touching the code, and we let it do its thing. It runs, it writes a new file called navbar. Right. CSS files, yes. I actually would prefer Tailwind. As a developer, at this point, I would probably prefer Tailwind, but also when it comes to getting the most out of AI coding tools, I think Tailwind is a better solution. Tailwind allows us to style our code in the same place that we sort of write the core layout of our web page, to put the styling with the content. By default, out of the box, Klein wants to use no Tailwind. In that case, the styles are in a separate file. And both for humans and for large language models, I think it's easier and more productive and faster to keep everything in context if those two things are in the same place. So Klein is done, and now it's asking to commit my changes. So let's go over what happened here. This is it. This is what Klein did. It redid our entire page. We have a nav bar now, a home. Welcome to the to-do app. Click the to-do in the navigation bar to get started. Boom. And we have a to-do app. This is something. This is really something. So that's what Klein did out of the box. I think it doesn't look great. It looks like really thin for some reason. But let's say that's a good first step. That's a good first step. Let's accept this commit. We want to commit this change, and let's talk about why Klein did this here. So Klein is this really powerful agentic coding tool, and I have certain custom commands for Klein. So if I come here, I have custom instructions. I say don't ask to start up the application or to use the browser, right? Because Klein sometimes wants to say, oh, can I launch your app in this browser here? I don't want that because I have the browser app running here. I don't want Klein to also be trying to launch the app. So that's a custom instruction. And I say after every task is completed, make a git commit with all outstanding changes and a relevant commit message. So this means Klein is handling the git process. The git process checkpoints my code after every change. So a change is made, and it's like a checkpoint in a video game, so to speak. So you can always go back in time to that state. This is very important because you can imagine asking for a new feature. Klein takes maybe 2 full minutes or whatever, makes a million changes to your code, and you realize you're not happy with it. You actually don't want that feature. It actually broke something. If you're not using Git, it is very difficult to roll back that change. So I tell Klein, make sure you're using Git. Make sure that after every task is completed, make a commit so I can always go back in time. That's that. So our sort of step one is done here. We'll notice, that if I refresh this page, my to-do list goes away. So let's make a few changes to this to-do list. First of all, let's ask Klein, new task. Please put some more effort into styling the to-do list. The list should take up more of the page. The page shouldn't be pure white. The button colors. Oh, but before we do this, actually, let me take a step back. Before we do this, let me just quickly get us set up with Tailwind. Please install Tailwind CSS and move all CSS styles. Can you see my typing here? Oh, I just realized you cannot. That's not good. Let's make a change. There we go. Maybe that's better. And move all my CSS styles into inline Tailwind classes. Okay, this is a very important change from my perspective. I think it will simplify the code from a human perspective and from an LLM perspective. I think that those two things really go hand in hand, and inline styles is going to make development easier for our tools. So let's make sure we do that. This is a fairly ambitious change. It means deleting all our CSS files. There's probably a few of those, and converting all that syntax for everything from that language into basically what's a different language. So there's a big translation project which we've just tasked Klein with doing, and let's see if we can do it. This is superhuman stuff, if it wasn't obvious already. Competent computer programmers can do this. Let me watch my stream really quick. I wonder if this format is really weird. I bet it is. Is it? Oh, it says not even live. What is happening here? Am I live or not live? Okay, good. I just clicked my stream here. And I'm not so disappointed in what I see. Okay. Hopefully we're going okay. All right. Cool. That makes me feel a little better. I was worried that maybe I was doing something wrong. All right. Let's continue. Save the changes. Whoops, that visualizes the change. You can see the new Tailwind CSS stuff. We've got to go a little faster. This is supposed to be a speed run. And we're going slow so far. Hopefully we'll pick up the pace a little bit here. Save my changes. All right, we're not reviewing anything. We're not double checking anything. See, this is a remove command to remove my CSS files. It's making a new commit. And when that's done, we can reload the website. And man, what happened here? Let's go. This is running. Yikes. Looks terrible. Looks awful. I know why. I need to restart it. I was wondering. I wasn't sure why it looks so bad. There's no styles on this page. I said, what happened to our new styles? So the answer is, I think we just need to restart the app, because when you install something like Tailwind, you probably need to restart the app. And indeed, after a restart, this looks better. Welcome to do. Okay, good. And so now we got that. This is not a visual change. This was purely an underlying code change with no visual ramifications. Let's keep rolling here. Now let's make some meaningful changes. Let's tell Klein, please make the following. Start a new task. Please make the following improvements to the to-do list. The page shouldn't be all white. There should be a neutral, modern looking color scheme. Buttons should have better colors. The width of the to-do list should be wider and take up a larger percentage of the page. Now, what else can we add? 4. To-do list items should be saved to local browser storage and persist between page refreshes. That is my request. This is our current state of a to-do app. we are going to hopefully improve it. And the reason we're doing this, by the way, is because I hope to use this to-do app to describe, to outline what we're going to build today. Because I want to build a few games. I'm noticing that Klein is hanging. That's not good. We're so dependent now on these AI tools. What are we going to do? Hopefully it will recover. Yikes, I wonder if API is down. Let's see, maybe we need a new API key or a new... Oh, there we go. Third time it worked. File not found. That's true, because we removed app.css. That's correct. Huh, it's sort of funny. I don't know why I was looking for a file that no longer exists. Interesting. But we'll see if it's able to make the changes that I requested now that we have it working. Save. I wish it would autosave. Commit changes. There we go. Man, colors are terrible. It's funny. This is from a previous version of the app. It's funny. I ran this experiment before, and it saved to local storage. So now it's reading my local storage on the browser and finding previous to-do list items. But those are now deleted. I refresh the page. Nothing happens. So now we can add items. So it's certainly wider. It has more of a modern 3D feel. You know, it's, I guess there's a real stylistic aesthetic question here that, you know, different people might have different preferences. If we had time, we would do dark mode, because I prefer dark mode, but we don't have time for that right now. So let's just make our to-do list. Number 1 is build a simple to-do list. Number 2, we're going to say make the web game, make the game 2048. Number 3 is make Tetris. We'll see how fast we can do these things. We're done with the first element on our list. Let's go. Number 2, 2048. New task. Please add a new page to the site with navbar link 2048 for the web game for a playable version of the famous web game 2048. Let's see if we can do it. You know, what we should be thinking about, what I'm thinking about, what I invite you to think about is what's next on the list, you know? If we can accomplish 2048 and we can accomplish Tetris, where do we go from there? What's the next step? What's harder? How can we really push these tools to the breaking point, basically? But maybe we're getting ahead of ourselves. Will it even succeed in this task? Remains to be seen. I noticed that it's actually implementing the game, which is nice of it. Now it's updating the navbar. Save. New root. Committing changes. 2048. Okay. Cool. Doesn't work yet. But it looks like something. So what do we do? What do we do? It's broken. We could tell Klein, oh, you know, it's not working, fix it. But that's not really what I want to do. Because in my experience, both as someone who uses AI tools and someone who knows what it's like to be a developer and can sort of imagine the perspective of the AI, so to speak, in a way, speaking metaphorically, we need unit tests, in my opinion. So the next step here is please add, let's take a look. Yeah, please add unit tests to validate the game logic in game 2048.tsx. This workflow is very helpful. It's helpful to have unit tests as a document to know, is your code working or not working? It's helpful from a developer perspective. If you're trying to fix bugs, implement new features, to sort of be able to isolate parts of your code and validate that they're working sort of in an atomic, isolated, sandbox kind of way. And by encouraging the LLM to do that, I trust it will give us better results than if we, try the same task without any unit tests. So that's the theory behind this. But of course, this is an adventure, and we're going to learn as we go, see what happens. So we can read here, game controls, allows starting a new game, tile colors, renders tiles with the correct colors. This is what we're testing. Updates board state after moves. That's a good thing to test. Save the game. Now it wants to execute the test command. That's helpful. And fails. Great. Responds to arrow key presses. Does not work. Renders the game board with initial tiles is failing. This is great, right? This is exactly what we wanted. We now have these unit tests which demonstrate the failure, the shortcoming of the initial pass. So we can commit these changes. Ooh, the test failures. Oh, see, Klein is so smart. The test failures indicate issues with how we're accessing the game board elements. The main problems are we're not finding any non-empty cells in the initial board. Board state comparisons are failing because we're not correctly assessing the tile values. You see how powerful this is? Now they all pass. Now they all pass. The AI was able to fix this code because we prompted it to write unit tests. This is the power of unit testing. Human beings know this. Competent, experienced software developers know the power of unit testing. And these lessons carry over beautifully to prompting AI. We commit our changes. And now we can have a moment of truth here. Is this going to work? Nope. So far, no luck. So let's see here. Let's say. So we can say, when I open the 2048 game, the board is empty with no numerical tiles on the board. Please add a new unit test to cover this failure condition. And that's all we want to do right now. I just want to add a unit test to cover this broken case of refreshing the page and not finding anything there. Let's see what it sees. I can see that the game should initialize with 2 tiles on the board. The current test suite doesn't verify that initial tiles are present. I'll add a new test in the game initialization describe block to verify the board starts with exactly 2 non-empty tiles. That's great news. We save. We commit. We refresh. No luck. Let's run the unit tests. Initialize with exactly 2 tiles on the board is a failing unit test. NPM test. No, that wasn't it. NPM test. Get the past the path. Okay. We have a failed case. So now we're going to ask it to fix this failing unit test. We're going to say, please fix this failing unit test. What did it find? I can see the issue now. In the game 2048 component, the initialize board function is trying to add 2 tiles by chaining add new tile calls like this. However, this isn't working correctly because the second call to add new tile is overriding the result of the first call. Interesting. We'll see if this works. If this doesn't work, we'll have a very interesting question. What do we do, right? Because you don't want to get caught in these loops of trying the same thing over and over again and it's not working. So, because human beings like LLMs can get caught, they can get stuck. And you can get into a state where you're saying, you know, fix it. It tries to fix it. It's not fixing it. So we need to make sure, well, the unit test passes. That's a good start. That's a good start. You know, we might need to think creatively about, oh, that's progress. Okay, great. That's progress. That's progress. That's starting to look like 2048. Arrow keys don't work. There could be more than one reason why arrow keys don't work. So before we worry about the keyboard keys, which could be a little bit tricky, depending on the way event handlers are wired up and whatnot, we're going to say, please add 4 buttons underneath the game board corresponding to the 4 directional arrows on the keyboard. Clicking these buttons should move the tiles just like the arrow keys on the keyboard. So let's see if we ask Klein to add buttons to explicitly move the tiles in that way, if that works. And depending on whether or not that works, we'll know what to do about the keyboard not working. So for example, if the buttons work and the keyboard doesn't work, we can say, you know, add a unit test to cover the fact that keyboard buttons aren't working. Hopefully that will fail and then we can fix it. On the other hand, if that also doesn't work, you know, well then that's a different unit test, but the same principle applies. Save. Okay. We got buttons here. Oh, look at that. It works. These colors are awful. Actually, not as bad as I thought they would be. Okay. These colors are workable. We have a working game. The keyboard buttons don't. Oh, they got restarted. This is weirdness. So weird. Okay, every keyboard button restarts the game. So interesting. So this works. Clicking on the buttons work. This is basically almost done. I mean, there's a little more testing we can do. We can check the end state. But this is a working 2048 game. Keyboard buttons don't work yet. Let's fix that. And then let's add some animations and let's call this done. So start new task. Clicking on the 4 arrow keys in the 2048 game. Let's say this. The 2048 game works when I click on the 4 directional buttons on the page. However, how big is this file, by the way? Okay, 250 is pretty damn big. My intuition tells me that when you get to about 300 lines of code, you're like at the limit of what the LLM wants to effectively deal with. So around 250 is a good time to say like refactor this, meaning break it up into smaller components, break it up into multiple small files. But we're so close to the finish line here that I think we're just going to try to roll with this and not do what the most prudent thing to do would be, which is probably to refactor this file. So let's just run with this. However, the keyboard keys, the keyboard buttons don't work. Please fix this bug. Let's just see if that works. Because we're so close. If that works, we can add some animations, which could be nice. It says, I can see the issue. The handle key down function's dependency array in use callback only includes board and game over, but is not using move board, which is not, but is also using move board, which is not included. This means the function is not being updated when the board state changes. Let's fix this by adding move board to the dependency array. Is that the correct fix? I mean, there's a lot more we could do here. We could ask it to fix the styling, which doesn't look great. We could probably improve the colors. But I don't want to spend forever on this. I mean, if once we really get the game working, I'd love to. Ooh, it's broken as can be. Wow, what a broken state this is. So interesting. Okay. Yeah. So let's pause that. Yikes. Yikes. Okay. Okay. The 2048 game is in. I thought we were gonna get it that time, but apparently not. Infinite callback loop. Yeah, I sort of dropped the ball a little bit. There's more than one way to do this. I can tell Klein that we're in an infinite callback loop and have it fix it. I'm tempted to do something a little different. I'm tempted. Let's try something a little different. Let's go back in time. This is a list of all the commits, all the changes that Klein made 70 seconds ago. Fix keyboard controls by adding this move board to use callback dependencies. This was not a fix. This actually created more problems than it solved. This was not the fix. So I'm going to just go back in time. I'm going to go up a commit. I'm going to say git checkout head. So now our code state is before we made that change. I went back in time. I undid that last change. And I'm going to say git branch dash f master git log cout master. Okay. This is some just Git housekeeping stuff to make sure that we're on the same branch. And now I'm going to ask Klein again, but I'm going to rephrase my question. I'm going to rephrase my request. So now we should be in the previous state where the buttons work and the keyboard does nothing. Yeah, so all Klein needs to do is make sure that the keyboard event handlers, okay, let's try this one more time. Currently, the keyboard, pressing the arrow keys on the keyboard is not updating the 2048 game state. Please modify the keyboard events so that they work exactly the same as clicking on the arrow key buttons underneath the 2048 game board. Let's try that. I'm hoping that by being a little more explicit about the nature of the bug and the desired fix, that we won't run into the same issue as last time. Uh-oh, I think we're doing it again. Okay. We might have to try something else. I'm reading from this response that it wants to make the same change, I think. The same change that led to a disastrous infinite loop last time. Let's see. Yeah, this looks like it's not going to work again. But, well, yeah, I see it. You can't see it yet, but this is the same bug. So let's yeah, I don't like this fix. I don't like this fix at all. So, I want to say, yeah, let's just say this change breaks the game by creating an infinite callback loop. Please try again. It creates a circular dependency since move board is recreated in every render. Trying again here. We can see how much these requests cost us. Save. That was 10 cents. Let's see if that's better. No infinite loop, but no keyboard presses. Interesting. Interesting. So let's think for a second. Okay, make a commit. Didn't do what I wanted. We're gonna ask it to add logging. Please add logging for every keyboard arrow key press. This will allow us to see if if the events are firing as expected. Are we seeing logging when I press the arrow keys? The problem with having such a large file is that it slows down this process because Klein wants to output the entire content of the file for every change. It's also expensive. I'm paying for these requests. So again, it's preferable to break this file up into smaller files. But I just feel like we're so close, seeing if I can get away without doing it. Okay. Save. It wants to commit the changes. That's fine. We come here, open up the console. Oh, what the heck? So interesting. So interesting. So now keyboard presses. Okay. Arrow keys still work correctly. This is the correct 2048 interaction. Keyboard presses do not work properly. But this is a totally different bug. It changes the state of the board. I'm keyboard pressing. It's so interesting. So basically telling it to add logging, why did that make a difference? Why did just adding logging affect what? Why did adding logging affect the bug? I have no idea. So strange. Oh well, that's the nature of coding for you. Coding can be really mysterious sometimes. I don't know why adding logging changed the nature of the bug, but it did. So what can we do about this? Trying to think of the best way to fix this in a AI agentic way. These are the kind of problems, right? I mean, coding is hard, and coding has its own set of problems that you have to think about and solve. Agentic coding with Klein, AI coding, has its own set of problems. And this is one of them. You know, what's the right prompt? It's a prompt engineering problem. What's the right prompt to Klein that will help it fix this issue? It's an interesting question. And I'm going to think about it for a second. Okay. We're just going to be super transparent, you know? We're just going to be super transparent. I'm going to tell Klein, you know, clicking the 4 directional arrow keys under the 2048 game board works as expected. However, clicking on the keyboard arrow keys gives a buggy, you know, doesn't. However, manipulating the board state by clicking on the keyboard keys doesn't give the desired result. How can I best how can we best troubleshoot this bug and understand why the two events lead to different game state updates. I'm just saying, how can we troubleshoot this? How would you fix it? It came up with a possible solution. I know that in previous iterations we hit a infinite update loop bug. I'm hopeful that this change to the dependency array won't hit that bug again. I sort of think it will. These are the new coding problems. AI prompting problems. The question is, how do we inspire Klein? Yeah, I knew it. Okay. I knew it. Nope. That's a shame. Okay. This solution, this last solution, this last code change introduced an infinite callback loop. So it is not an acceptable fix for this problem. Please undo the last change and try a different approach. Okay, it wants to undo the change using Git. Nothing wrong with that. I support that. Now it's trying a new approach. Okay. This works. That's the buttons. Arrow keys are working. Good. We did it. We did it. This is 2048. I love this game. We can test that the game ends when it's supposed to end. You know, so I could try to lose. You know, doing pretty well happens to be. I could try to play worse. Oh, it restarted. Game over. Click to try. So it automatically restarted a new game, I think, when I press the keyboard button. Interesting choice. Now I have to press new game. Yeah, so that's buggy. That's buggy. We can also add animations, but we're going to stop here for this. You know, how long did that take me? If I had to estimate, maybe like 35 minutes or something like that, 40 minutes maybe. I'm going to call this a success. There's plenty of things we could do. Like I said, fix the end state, fix game over. We can imagine a high score leaderboard kind of thing. We can imagine writing an AI to play this game if we wanted to. And yeah, animations would be nice, but we're going to call this done for now. 2048 is done for now. So let's check it off our to-do list. And let's try Tetris. Tetris I found is harder. But hopefully using sort of the skills that we've learned so far, we can make it happen. Please add a new tab to the nav bar for Tetris. Start with that. Okay. Look what we have here. Wants to commit the changes, please. We have Tetris coming soon. Great. Start a new task. Let's say, please implement the game Tetris in Tetris.tsx. Oh my. So this is a big file. You know, one of the first things we're going to need to do is to break this up. Yeah, like I said, when we get to about 250 lines, 300 lines, that is too much. It's you know, depending on the context. I mean, it's not always too much, of course. There's no hard rules in programming, but it's often too much. Cool. Look at this. Tetris is happening. Look at that. Look at that. Completely broken, but beautiful. Beautiful. So pieces are spawning on top of each other. The game is not ending. Keyboard keys do nothing. There's a pause resume, which is cool. Completely broken, but beautiful. We're on the right track. We are cooking with gas, as they say. Let's do this. Please break up the file. Tetris. Let's say please refactor. Sex. And break it up into smaller component to smaller files, let's say. Please add unit tests for all the functionality of this file. This is the way to go. These are the workflows that I think are the prompting skill set for AI coding. First pass, refactor, unit tests, you know. And there's some other skills, some other tools, which I think we're going to have to look at to get this working. Because Tetris is a pretty tricky thing to build. It's a complicated game. It really is. I think most competent, strong humans would take hours and hours to get a working version. You know, there's some people out there who are, you know, much more talented than me, could probably do it faster. But I think if you're looking at the, you know, middle of that bell curve of competent software developers, it takes a lot of time. So when you're dealing with such a complex game like this, it's going to be a challenge from a agentic AI coding perspective, and there's, you know, going to be, you know, new tools that we're going to have to call upon to make it happen. So we see here a new Tetris folder with a bunch of files in it, constants, game utils, and a use Tetris React hook. And this sort of, we're all drawn from this original Tetris.tsx file. Excuse me. Okay. Unit test, great. That's very important. Very important. Should spawn a new piece. Should move pieces horizontally. Should not move piece when game is paused. Should rotate piece. Should toggle pause state. These are great. Should reset game state. Beautiful. It's fixing linting errors. Yeah, you know, for AI coding purposes, you could probably turn off this linter. It's probably not adding any value. It just imposes certain rules on how the code should look that I don't think AI really needs to worry about. So anyway, but we're not going to do that now. For now, we have a linter, so there's an extra pass, which we do to clean up the linter, to clean up those minor stylistic choices. Okay, more tests. This one shows game over state. Okay. Linter. Yikes. Fix a TypeScript error by using the correct testing library query method. Okay, so that's actually a real error. Never mind. Okay, save. Yeah, this Klein tool is something else. Very, very superhuman. As a software developer, this is a little freaky. I'm not going to lie. This is the future. I mean, I can't code this fast. That's the truth. It's doing, very human things. Updating the files, noticing errors, noticing problems, going back, updating them again. This has been 30 cents so far for this particular task. Okay, this removes everything from tetris.tsx. Tetris.tsx now just pulls in from this Tetris file. Okay, wants to make a commit with all these changes, describes exactly what was done. Now we want to run the tests. Moment of truth. That failed. That failed. No tests found related to files changed since last commit. Press A to run all tests. So I press A. Now it's going to run all tests. Great. We have 5 failed tests. The errors are visible here. That's great. Is Klein going to fix these errors? Okay. Let's see here, please. Let's say just proceed. Yeah, proceed is probably what we need to do. Okay. I see several test failures that we need to fix. Correct. Oh. So now it's I'm not thrilled that it's modifying the tests, to be honest. It's sort of the wrong approach. But, we're getting there step by step. So it's modifying the tests. And test suite failed to run. More errors. This is work. I mean, software takes time, right? Also for LLMs, also for AI. It has to write the code, run the code, rinse, repeat. The O-piece rotation test is failing because the shape comparison is incorrect. Okay. The use Tetris tests are still failing. At a certain point, we'll have to abort this approach, because if it only focuses on changing the tests and not changing the underlying functionality, the underlying functionality, I think, is buggy. So it could be a little stuck. Yeah, I'm afraid it's stuck. I'm gonna let it run this update. I don't know exactly what it's doing, but we're gonna have to cancel it after this because I don't feel like it's actually making progress. I'm not confident that it's actually making progress. Yeah, we're gonna cancel. I'm not gonna let it try again. We're done. This task is over. I spent a lot of time on my unit tests. Oh God, it's broken. Oh no. But we're gonna just pass in this error and just focus on this error. We're sort of gonna start again. I'm seeing the following error when trying to play the Tetris game. Let's see if it can fix that. Okay. Okay. Ooh, what happened here? This is different. This is quite different. We have a working Tetris game now. It took a while. Does this part work? Oh my God. Oh my God, that was easier than expected. The last time I tried this, it took more finesse. It took more fancy techniques, which I'll explain in a minute. But let's see if we can fix the fact that the page is scrolling. Let's start with that. Yeah, this is cool. It wants to run tests now. I'll let it. I'm afraid if the tests fail. Oh, tests all pass. Great. Great. Now we're really doing great. So we're in a good state. Makes a commit. Now we need to say that the arrow key shouldn't scroll the page. Okay. New task. That was only 10 cents. Please fix the Tetris game so that the arrow keys don't scroll the page when playing. Just adds prevent defaults. That should be the solution to that bug. And I think it did that correctly. We can look at the scoring of the game. And then maybe I'll leave a note on sort of how I had to get this working last time. And then we'll probably call it a day. And I'll leave it as an open question to you guys about what we can do next, how we could push this further. I'm not seeing a restart button. That's sort of funny. Not ideal. Definitely gonna want a restart button. But let's see the score, how the score works, if it's working at all. That's disappointing. Can I squeeze you in here? No, didn't let me. Okay. The score is currently 100. And I could have cleared a line, but I want to clear 2 lines if I can. 100. I can clear a line here, might as well. 200. All right, I mean, it's basically working. It's giving me 100 for each line. I'm about to clear 3 lines. What is that, 500? Yeah, so it's 100 per line. Okay, it's something. I mean, we could obviously iterate on the scoring. It needs a restart button. But this was easier than in previous experiments. So in previous experiments, I had to apply some more tricks. Some more tricks of the trade, which I actually didn't have to apply this time. In previous experiments, it was buggy. Like the bricks weren't falling. There were sort of subtle bugs about understanding the top versus the bottom of the board. Hit testing. So what I said was as follows. I told Klein, create a debug mode. Create a debug mode for the game. In a debug mode, the game loop is off. this game loop, which causes the pieces to fall, this tick of the timer where the pieces drop, is off. And there should be a button to iterate forward, step by step. And there should be buttons for all the keyboard presses for the up, right, left, and down, corresponding to the 4 keyboard moves for rotate, move, and right and left. And add logging about where the pieces are and all that. And when those things were visible, it was very easy for me to tell Klein, this is what I'm seeing in the debug panel. This doesn't make any sense. Basically, I think the bugs that I was seeing were related to misunderstanding the top versus the bottom of the board. But when those tools were there, when it was easy to go step by step and show the state of the board and communicate that to Klein, it was very easy for Klein to fix it. So those are some of the tricks of the trade. This has been about an hour of agentic coding. I'm satisfied for now. We can knock Tetris off the list. That was at superhuman speed. Not me, and no one I know can make a working version of Tetris that fast in the browser. I'm sure there are people who can do it. Don't get me wrong, but it's pretty exceptional to be able to do it that fast. So what's next is my question. How can we push this further? How can we really press up against the limits? Maybe we'll do. I would love to do some cool physics stuff, some fractal stuff. So let's do next on our list, icing model simulation. I have a book downstairs of computational simulation stuff. Maybe double pendulum stuff like this would be fun. So this is sort of what I imagine next. If you have any ideas for cool projects like this, animations, physics, things like that, or anything, any games that we can do, let me know, and let's continue to explore how far we can push this technology. Thank you for joining me today. If you did, hope to see you again soon. Like and subscribe if you enjoyed this. See you later.